talk about the volume. What's the volume of something?
It's how much fit in it.
Yeah, how much I can fit in it, right? So we think about, again, I always go back to the trusty old Kleenex box. Inside, right, is the volume. So when we're talking about volume now, my label changes to what? Cubed, right? So the label is cubed. And why is it cubed? Well, basically the same reason that it was squared, right? Now we're going to multiply three things together. Okay? Now, in the other class, Kenzie says, well, this quiz is going to be hard because there's a lot of formulas to remember, right? And there are. But we're going to have more formulas today, so when we get to the test, not only will you have the surface area and lateral area, but you also have the volume. The nice thing about volume, though, is that basically it repeats itself over and over again. So you just have to remember how to kind of manipulate that same formula. So we then want to say the volume of a right prism. What's right mean in that case? That it's what? It's basically a 90-degree angle, or it's like a perfect square, right? So it forms that 90-degree segment, or shows the box in my figure. So when we have the volume of a right prism, again, we're going to say capital V, and again, it's really important that I use the right letter, is equal to capital B, which is what, do you think? Area of my base. And how do I know what my base is again if we're talking about prisms?
It's going to be just whatever you want.
How do I know if it's not this kind of a prism?
Oh, it has to do with the shape, whatever the shape.
Whatever the shape is, right? And how do I know what the shape is? Well, obviously it's going to be different, but what are my faces or the middle part? They're all rectangles or parallelograms, right? So you got to remember that. So again, the tough one is this right here, right? Because it's a rectangular prism and there's a lot of different rectangles, right? So which one do you see as your base? Well, normally in this one, it's probably what you sit it on, right? So Aiden looks at it and he says, well, I think it's the top and the bottom because it's sitting on the bottom. Braden looks at it and he says, well, I think it's the sides. Okay? It doesn't really matter what you're going to do because what we finish it out with is capital B times H. And what do you think H means in this case? This is the height, but it's the height of what? What does height actually represent in this? It's the distance between the bases. And this is where we would have that box in the corner, right? To form that right angle. So again, going back to this now, if Aiden saw it as the top and the bottom, right? His area of the bottom is way bigger than Braden's area of the side, right? Just because it's bigger. But notice Aiden's height would be a lot shorter than Braden's height between these two, right? So no matter what you do, they're going to even each other out. So it doesn't really matter. What makes this one a little bit more complicated, so yeah, it's capital B times H, but then the area of the base could be anything like you said, right? So when we're talking about the area of the base, this is where we go back to those parallelograms. Could be a what? A triangle. It could be a trapezoid. It could be a regular polygon. So again, we've written these down more than once. If you don't have to write it down, don't write it down. But just remember, especially with the parallelogram, the triangle, and the trapezoid, my height in base times height, or base times height divided by 2, is always where it makes that right angle. So it has that box. Even in my trapezoid. Sometimes, though, those heights might be on the outside of the figure. Just remember that. And they usually then have a little dash line, and we'll actually have an example to show that in our examples. And then don't forget our regular polygon. This is one of the ends of my prism, or any other shape, basically, right? And regular means that it's a perfect shape. Okay? So what's my formula for a regular polygon again? 1/2 PA, capital P, little a. Capital P is my perimeter of my base, little a is my apothem. And then I have to go through that whole process of finding that apothem, right? I take that polygon, I divide by the number of sides from 360. That gets me that central angle. And then when I draw my apothem, I divide that central angle in half, and then I have to use either SOHCAHTOA or my special right triangles. Okay? Questions with that? So, then we move on to a right cylinder. And a right cylinder is even more simple because why? Well, we always know that a cylinder is going to have a base of what? A circle, right? So, remember when I said it's easy because the formulas are all the same? We can still use capital B times H. So it's the exact same formula. But to make things easier, at least for me, I'm going to simplify this because as you just said, my base is always going to be a circle. So what's the area of a base? So I know that pi r squared H is actually the volume of any right cylinder. So again, when we say a right cylinder, this means that my cylinder is basically a perfect one, up and down. All right, so we have something like this. And my height could either be this side, or it could be this axis down the middle, remember? And if it's the axis down the middle, then they'd have to put the box in there. But again, we need a height, a distance between my two circles. Now the ones that get a little bit different are, what did we call it when the cylinder slanted? It was oblique, right? And so when we have our slant here, there still might show us the axis. And this is where, don't get confused if you start going fast. And the first one I could use the axis because it was right down the middle and it made a right angle. But this one I can't because there's not there. So where's that going to occur? Well, they're going to have to draw me another height somewhere and put it there. They might actually have that height way off to the side, outside of my cylinder, so it's going to tilt that much that it's way on the outside. That's totally okay. And so then I just have to make sure, notice that when I drew this height, I'm going to use that axis and whatever my distance is between the center and where that 90-degree angle made, but notice that I made a right angle there, or a right triangle. And so this axis now would act as my hypotenuse, which is C, and then I don't care what A and B are, but I would use probably Pythagorean theorem. I could use trigonometry in that also, and we'll show you examples of that too. So realistically, when you get to volume, it does simplify a little bit because it is the exact same formula. You just have to know how to manipulate that capital B, meaning what is it actually going to be. Okay? Piece of cake, right? So, let's look at a couple and then you have the rest of the time to work. What? Don't care about him. I don't know what that one is. So here's my first one. Now, we're going to give you a little cheat system here. A lot of you like to take shortcuts. Realistically, in prisms, okay, especially rectangular prisms, like our old Kleenex box again, they're going to probably give us 3 numbers in the problem. Because they're going to give us this, this, and then that. Right? Yeah, realistically, the cheat code when you're looking at prisms is that you can take those 3 numbers all the time and multiply them together, and probably 80% of the time you're going to be right. So the only thing that we'd have to do different in a triangle is divide by 2. Now we're going to show you one of these here shortly that it doesn't work. So you do have to slow down a little bit and actually look at the problems and don't just assume that the 3 numbers are automatically going to be able to be put in there. But in this particular case, does everybody see that this is a triangular prism? Because my triangles are on the base, on the ends. Even though it's not sitting on that triangle, it still has to be a triangular prism because all of my guts or insides are all rectangles. Okay, so in this particular case, I'm going to take 12 times 10 divided by 2 times 25. Or I can multiply those 3 numbers together and then divide by 2. Doesn't really matter when I divide by 2. Everybody good with that? Do you need to see the math? Yes? No? The only thing that we have to remember at the end is what? Centimeters cubed. Don't forget to cube it. And don't be shocked. A lot of volumes are what kind of answers? They're going to be pretty big because I'm multiplying three numbers together. Okay? So that one was pretty easy. This is the one right here. If you would kind of use my cheat system, you wouldn't get it right. Right? Because the three numbers don't give me the three numbers that I actually need. Everybody realize what I'm saying there? So again, what kind of prism do I have? I still have a triangular prism, right? Because the triangles on the front and back are actually my bases. But remember, for my base times height in my triangle, in my triangle, I need that box to have numbers. Well, this one doesn't. So I have to realize that this face right here is a rectangle. So if this is 30 inches, this over here is 30 inches, which actually acts as my what? My hypotenuse. And so can I find A then? Then I'm just going to use what? The Pythagorean theorem. So I do A squared plus 18 squared equals 30 squared to get my A. Then I'm going to take this times this times this divided by 2. Make sense? Okay. Anybody need to see the math?
Yeah.
So if we first find the A, we would have what? 900 minus 576. Whoa.
Wait, why'd you minus it?
What did you say?
Why'd you minus it? I just subtracted it.
I didn't subtract it. Oh yeah, I subtracted it. Because I had the hypotenuse and I had little b, right? To find my A. This right here is 30, right here. That's my hypotenuse. So I would take this squared is equal to this squared plus this squared. So I need to bring this to that side, so I'd subtract it. So this was 24, right? Yeah. So I'm going to take 9 times 24 times 15. All I did was divide this by 2 first. It doesn't matter when you divide. So I got 3,240. Is that what you got?
Yeah.
And we are correct. So then we move on to a cylinder. Again, we're using the same formula, but we can simplify the formula right away. 2 pi r squared h. So do I have everything that I need? Yes. So notice my axis in this case is my height. They could have actually put the height over here and put a box. So essentially in this problem, I'm actually taking pi times 1.8 cubed, right? Because my height and my r are the same things in this problem. That won't always happen, but it happened in this problem. Everybody good? And then don't forget it's centimeters cubed. Okay?
Wait, what was it?
Answer is 18.3.
Oh,
Right here? Yeah? So the next one's pretty much exactly the same. And then we get our little weird shapes. Okay, so find the volume of the oblique cylinder. So here's the question. Notice where my height is in this case. It doesn't go straight down the middle. It comes out to the side actually. And then they put their box. So I still know that this is my height. Now here's the question. Does this little extension part matter in the problem? No. Because all I'm concerned about is the height, right? So I have my radius here, which is 15 squared times 25 times pi. For a grand total of 17,671. So again, don't get alarmed if the numbers are really, really big. But what I wanted to point out is that this right here does not matter in the problem. And then obviously we'd have feet cubed, right? Because I'm taking this, times this, which are all feet. Pretty much the exact same thing. And I think that's it. So, questions with any of those? So again, like I said, the examples, there wasn't a regular polygon in it, so again, you'd have to go through that process of finding that apithum and then finding that base first. And essentially then, you don't even have to do 1/2 p times a because you're gonna multiply by 2 because there's 2 bases, right? But that's a whole different story in some of the problems.